Number 10, which correctly describes the roots of the following cubic equation. Fastest way to do this one is to go to your calculator, go to y equals x to the third plus 6x squared plus 11x plus 6. Go ahead and graph that. Let's zoom in a bit. Okay, so this is an x to the third, so there should be 3 roots. And I see 1, 2, 3 x-intercepts. So that means that I have 3 real roots. And so that narrows it down to C or D. And the reason they're asking 2 of which are equal in value or 2 with it, each with a different value, they're asking about those multiplicities again. So because the graph goes straight through each of these points, that means each one's only a root once, right? There's 3 different ones and they're all 3 different numbers. Instead of a graph that might look like this. Okay, like let's say this is an x equals 2 and this is an x equals 4. There are 1, 2, 3 real roots, but this is a multiplicity of 1, this one is a double root. So it has the same value. So if you're writing it as a factor, it'd be x minus 2, x minus 4, and the x minus 4 would show up twice. There's 2 of them. Or it would look like this. Okay? Multiplicity of 2, multiplicity of 1. But in this case, they each cut through straight through. Nothing is bouncing. So for this one, we have one at -1, -2, and -3. So what it would look like in the equation would be x plus 1, x plus 2, x plus 3, and each of those has a multiplicity of 1. None of them are repeated. So there's your 1, 2, 3 real roots. Each of those roots has a different value. It means none of them are repeats. They all have a multiplicity of